Hello guys, welcome back to our channel Career at Market Value. So the topic of today's discussion is the last two remaining GARCH methods, that is I GARCH normal and I GARCH students T. So in the last episode you might have been aware where we have computed GARCH through GARCH M students T distribution. So for I GARCH things are pretty easier. So first of all we need residual square, which we can easily compute by raising residuals to the power of 2. There we go. Maybe convert this into percentage. Okay, so we'll drag this down. There we go. Okay, and then we'll move to the long run VAR estimation, which will simply be this. Let's copy the format. Okay, then standard deviation will simply be the square root of this, and value at risk estimation would be simply norms inverse. Probability is a 5% for 95% confidence interval, and multiply this by standard deviation. There you go. Okay, so we'll move forward with 97.5 with a 2.5% confidence interval, then 99% with 1% confidence interval, and then 99.5 for 0.5% confidence interval. Now we'll move to E-views for the equation and the coefficients for estimating I GARCH. So let's start from quick estimate equation, and our date will be 11th of November 2010 for 70% of our data, which ends at 11th of November 2010, and this would be ARCH. And then the model specification will be GARCH and TARCH, ARCH1, GARCH1. This will stay as same because we are estimating I GARCH 11. ARCH M will be none, error distribution will be normal, and the restriction we will keep as I GARCH, right? We'll press OK. There you get your sample equation and the statistics. So first of all we'll copy the coefficients. Okay, so the first coefficient is this. Let's copy this. Sorry, the first coefficient is this. So we copy the coefficient and paste it over here. And the next one down below. There you go. I've copied the coefficients. Okay, now I'll copy the equation. This is the simplest form of GARCH equation. Let's copy this and let's keep this as here. So GARCH equal to, or variance is equal to C2, which is this, the coefficient adjoining the residual. So we'll simply put an equal to sign, open brackets, C2 multiplied by residual n minus 1 square. So this is residual square and n minus 1th point is this, close brackets, then coefficient attached with the next variable. We'll copy this and it simply says plus of open brackets 1 minus our again open brackets our coefficient, close brackets, and then multiplying this conjugate. So we'll again put and the bracket for this whole conjugate to enclose, multiplied by GARCH minus 1 or variance n minus 1, which is this, right? And then again enclose this in another bracket, right? So there you go. So Excel is proposing some, okay, so there you go. So our equation estimation is done. So this is our variance value, and other things for standard deviation and value at risk for the different set of confidence intervals will remain the same. So I'll simply copy this down, change the color, and simply drag this down. So our estimation of value at risk with GARCH 1 normal is complete. So I'll delete this and delete this as well. So yeah. Now you'll go up and we'll estimate I GARCH with students T distribution. Okay. So let's change the naming convention to students T, right? So the value at risk and standard deviation will simply be the same. So you can directly take that from here. Say here and copy the format. Standard deviation will also be the same for long run variance, and the residual calculations will also be the same, obviously. So residuals will simply be this receipt, sorry, we can place an equal to sign and directly link this to the residual square we have already calculated, right? So there you go. And since it's a student's T, first we need to look at our e-views for the equation and coefficients, right? So we'll go to e-views, close this page, okay, move to quick estimate equation. This is our equation, and let's state our 70% data value as 11th of November 2010, right? This is still our 70% data. So we'll move to Arch, everything will remain same, just change restrictions to I GARCH and error distribution from normal to students T and press OK. So there you go. So first thing, we need to copy our degrees of freedom, which is this. So let's take that over here, degrees of freedom, yep, which is this. Then the value of the coefficients, you can take this as a whole, okay, paste this here, okay. So now we need to copy the last thing, that is the equation. So there you go. So first of all, we will estimate the value at risk with this degrees of freedom that we have got. So for students T, we will apply minus of T inverse, right? So T inverse, it's asking for probability, we will state the significance level and then the degrees of freedom that we got from EQs. So there you go. See the number. Okay, so we need to multiply this as well with standard deviation. I missed that. Yeah. So now we'll simply need to copy this and state our respective significance levels. For 97.5 it will be 2.5. For 99% this should be 1%. For 99.5 this will be 0.5, right? There we go. Now for the next set of values, it simply states C2, which is this, the coefficient. We'll copy this, go over here. It says I'll open brackets C2 multiplied by residual n minus 1 whole square, which is this value. I close my brackets. Then it says then everything relates to the next set of coefficient. So plus of open brackets 1 minus again brackets this value close brackets, then multiply this conjugate by GARCH n minus 1, which is this, or variance n minus 1, right? And then we'll close the brackets over here and again on final bracket for this conjugate to close. Okay, and convert this into percentage. Okay, so there is one error. Okay, I got the error. The error is simply 1 minus this conjugate multiplied by the value at risk. 1 minus this conjugate multiplied by the long run variance. So yeah, this is it. So we'll delete one extra bracket that was there. Now press enter. Okay. So yeah, there you get your variance, and the rest of the things will remain same. So I'll simply copy this down below. Okay, and drag this till end. Okay, there you go. Okay, so now the estimation is complete. We'll delete every other thing. Okay, so the value at risk model building exercise is the estimation exercise is almost complete. We have estimated all the models. If I open this pane in the past videos, if you take a look at them, we have covered historical simulation, JP Morgan risk matrix, then GARCH 1.1 normal, GARCH 1.1 students T, I normal, I students T, PARCH normal, PARCH students T, GARCH normal, GARCH students T, and I GARCH normal and students T. So all of this estimation is based on ARCH 1 and GARCH 1, that is all of them are GARCH 1.1 models. Okay, so in the next video guys, we'll do a back testing in all of our models that we have estimated and find out which one is the best model. So stay tuned for that, and do subscribe, share and like our video. If you like this channel, like this video, and comment down below. Thanks guys.